Okay, so today I will talk about Java. So I had the link guru file.com. You can access it and you read about OOP, about Java Basic. Yeah, very cool. So I will shoot the C++ and Java are different. First, you see it here, yeah, and you translate it. I'm lazy and okay. Oh my god. Okay. So this here about Java interview. Okay. You what is
Before we introduce the Java platform, how about answering a very basic question? What is a PC? Take your time. The dictionary definition of computer is that it is an electronic device capable of performing computations. It has many peripherals like a monitor and keyboard to accept or display data to users and memory to store information. But the heart of the computer is its processor, which does all the thinking for the computer. Coming back to our definition of computer, you may have noticed the keyword electronic. Thinking of it, if a computer is an electronic device, how can it understand and display text, images, videos, and other rich media information? Well, a computer understands only electronic signals, where a 5-volt current represents a binary 1 and a 0-volt current represents a binary 0. Your PC is continually bombarded with these electronic pulses, which it interprets. 8 bits of such signals are grouped together, and text, numerical, and symbols are identified by unique patterns of these 8 electric pulses. For example, the pound symbol is represented by the pattern 10101010. Instruction to add two numbers is represented by pattern 10000011. This is 8-bit computing. Current-day processors are capable of understanding and decoding 64 bits at a time. Suppose you were asked to write a program to add two numbers. Say add 1 with 2. Assembly language is the most elementary form of software development languages. Your code to add two numbers in this language would look like store number 1 at memory location, say A. Store number 2 at memory location, say B. Add contents of location A and B. Store results. The way you feed this code to the processor would depend on the PC you are using. Back in the 50s, when computers were huge and consumed a great deal of power, you would convert your assembly language code into corresponding machine code of ones and zeros using mapping sheets, and punch the machine code into punch cards, and then feed those punch cards to the computer. With advancement in technology, I/O devices were invented. You could directly type the program into the PC using a program called assembler, convert it into corresponding machine code, and feed that to your processor. That apart, you will also have to make calls to operating systems providing functions to display the output of code. With advancement in software development languages, this entire assembly code could be shrinked into just one line, print F 1 plus 2. A software called compiler is used to convert your C language code into assembly code, and the assembler converts it into corresponding machine code. Though present-day compilers come bundled with assembler, they can directly convert your higher language code into machine codes. Now, suppose Windows operating system is running on this Intel processor. Combination of operating system plus the processor is called the platform. The most common platform in the world is the Windows and Intel, called the Wintel platform. The other popular platforms are AMD and Linux, PowerPC, and Mac OS X. Now, with change in processors, the assembly instructions will change. For example, the add instruction in Intel may be called addition for AMD or math add for PowerPC. And obviously, with change in operating system, the level and nature OS level calls will also change. As a developer, I want my software program to work on all platforms available to maximize my revenues. So I would have to buy separate compilers which convert my printf command into the native machine code. But compilers come expensive, and there's a chance of compatibility issues. Enter Java language. The code to display addition of two numbers is system.out.print in 1 plus 2, saved as a .java file. Using the Java compiler, the code is converted into an intermediate code called the bytecode. The outcome is a .class file. This code is not understood by any platform, but only a virtual platform called the Java Virtual Machine.
Okay, done.